Hello, everybody, and welcome back to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I am your host, Tina, and today with me, I have the wonderful, incredible guest, Mike, who's going to be walking us through Redwood and the multiplayer experience that goes along with Redwood. So I'm going to just hand it over to you because you're going to have a vastly better explanation than I do, and I'm sure there's a lot to dig into. So to start us off, Mike, why don't you tell us a little bit about yourself?
Sure. Thanks, Tina. My name is Mike. I'm the lead developer at Encanta Games, where we focus on building high quality developer tooling and middleware that's designed for studios of any size.
Fantastic. And I'm ready to dig in because I think if I remember right, there's quite a lot to go over, really.
Yes.
All right. Well, let's do
Uh,
it. Let's take it away.
cool. So if you could go to my screen.
There we
Um,
go.
Great. So today, we don't have any great looking cinematics or beautiful shots or great looking game mechanics. We're focusing on something a little bit different today, and that's live service multiplayer online games, backends, and how you can get started with those. Um, we got a lot to cover. I tend to ramble, so I'm going to try to keep things brief. But if there's something you want to dive deeper in, feel free to ask a question, and we'll get to that later. So, what do we think about live service multiplayer online games? What comes to mind? We might think of shooters like Valorant or RPGs like WoW. And we can't be on Inside Unreal without mentioning Fortnite. Some people might think that multiplayer games, oh, that's the replication. That's how we sync stuff from the server and the client and using remote procedural calls, or RPCs for short. But what many people don't really think about, because it's kind of hidden in the back end, is the back end. It is thought to be this scary thing. Maybe there's some engineers in a dungeon somewhere duct taping and hot gluing a bunch of stuff just so that the game is beautiful and running smoothly. And while much of that might still be true, it's really not that scary to get started with. So hopefully today we'll try to demystify some of what goes on in a backend, what are the different options, what's best for you, and how you might get started with one.
I'm
So,
looking forward
what
to
makes
it.
up? Sorry.
I'm looking forward to it because I know for
Awesome.
me, it's always seemed like probably one of the harder parts of developing, especially for a larger multiplayer game. So,
It's usually something that's like for traditionally medium plus studios because it just takes a lot. You have to build not just the game, you have to make it multiplayer friendly, and then now you have to scale it with a bunch of server infrastructure. But hopefully, we're going to try to make it so that, you know what, it's not just for the big studios, the indies can do it as well. So, what makes up a live service multiplayer game? Well, first is the game itself. That's Unreal, the client, and the server. And they're going to do a bunch of syncing and stuff. But the backend handles a little bit different than dealing with the game. It's in charge of managing the game and making sure everything happens, but it's a little bit separate. And so, what the backend usually consists of is the following. First, you have authentication. Players have to hit some server somewhere and say, I would like to log in. Uh, Usually, you'll either use like an email password, or you'll use like a service like Epic Account Services. And once you're authenticated, you're going to have some data that goes along with that. So there's usually a database of sorts, and that's going to have like the player's data, for example, username, their display name, what their character looks like, things like that. You're going to also have world data, things that are what maps are being loaded, what kind of persistent information is part of that, and so on and so forth. And then, really, to kind of bring everything full circle, once they're logged in, we've got our data, you have to get them into a server. That's really the purpose of a backend. There's a lot more that goes into backends, and depending on your game, you might need some more features. But at a core, this is what goes into a backend. And like I said, that we got all these extra features. Here is just a few of the things that you may need in your game. There's usually kind of social, economy, telemetry, API. There's a lot here. If you want to dive into one of these, feel free to ask a question, and we can try to cover a little bit more of what my thoughts are about that. Redwood has a handful, if not all of these on the roadmap. But yeah, we're going to be covering today mostly about the foundational side of things so that you can get started with the backend and then you can grow into adding these extra features to support your game. So when you have a backend, you have a couple of different options. The first is a service-based option, and those are going to be your Epic Online services, PlayFab, Steamworks, and there are a few others out there. And they're really great because you can get something up and running very quickly. And like Epic Online Services has some integration into Unreal, so you can use that just ready to go. There's a couple of extra plugins for the other ones, so it's just something that you can just get started with, and it's a great tool. There's usually low or even no cost. Some will get expensive as you like scale really, really, really high. But at the end of the day, they usually have low or even no maintenance. Someone's running that service for you. You don't have to have the backend servers running somewhere on the cloud. You don't have to upgrade them. You don't have to do database migrations or anything like that. It's kind of handled for you. And they support a lot of the features that we just saw. So you might be asking, okay, so why would we use anything else? We've got low costs, low maintenance, stuff does all the stuff. And it's easy. Well, some games need something a little bit more than that. And usually when we talk about scaling, like massively scaling, your games are going to have an interesting game mechanic, whatever that hook, that twist is. And those services just don't quite get you all the way there. Perhaps you need more control. Maybe you have an RPG and you need to have your databases close to where the servers are, which is where the players are. Where these services usually will have like a centralized place on the earth where all the data is stored. And so people that are on the other side of the earth have to go all the way across to go get that data. And there's a couple of other things that you get extra control if you like self-host your backend or something like that. If you want something that's more complex, you want to have this very specific little teeny tiny feature, and that's additional to what the service provides. Well, you can't really add it because all that logic's happening on the service, somewhere external to you. And now you want to add this extra service to do this thing. Well, now you have to spin up a whole slew of extra backend stuff, the bare minimums, the foundational work, just to add this little bit of extra functionality. And your requirements are going to change, especially as an indie. You're going to start somewhere smaller. And as you get more players interested, start doing play tests, and now you're actually releasing and launching. And now you're like, oh, wait, I need to scale a lot more because I did it. I made it viral. Well, you need to be adaptable about where are your servers located? What are the different features? Maybe you need to change your matchmaking functions to support this new demand. And if you're using a service-based option or something like this, sometimes it's just not really flexible in that way. So Redwood tries to cover these foundational pieces, give you as much control so that you can figure out where your servers are located, where the databases are located, giving you the adaptability so that you can add those complexible features. But before we get into what Redwood is, you might be saying, okay, I need all this control, so why don't I just build it myself? Sounds pretty simple. Just have to have the authentication. That's pretty easy. Data, it's just a database, and getting players into a server, yeah, we might be able to figure that out pretty easily. So I would just, it's just not gonna work out. And it's a little hypocritical for me as a person that was an indie developer that built a backend telling you to not build a backend. And I feel that. But hopefully I went through that so that you don't have to. And hopefully Redwood can kind of give you that starting place so that you just don't have to do everything that you have to do to build a backend. So let's go into kind of what a backend does. Just kind of overview of what the process kind of looks like. We kind of talked a little bit about this, but we have a player, they log into a backend. This is like a process, yeah, a process that's running on a server somewhere, and you run a script to execute it, and you get this login authentication. It talks to the database to go get the player data and sends that back to the player, Unreal client. And this player is like, great, I would like a list of servers. I would like to join a server. And the backend says, okay, great, hit the database. Here you go. Here's the list of servers. And the player is like, okay, I want this server. This is the one I want. Can I join it? And we can't just let the player join the server directly because we need security as well. We need to make sure that the player is actually who they are, and the backend has already authenticated them, so the server shouldn't do that as well. So they're going to ask for the backend for permission. Backend's going to say, yep, you're good. We're going to create this token so that we can send to you. It's like a one-time use token. And we're going to store this in the database so that when you join that server, we'll be able to authenticate you. We go ask the server, hey, can we join with this token? The backend said I could. And the server's like, yeah, okay, let's double check that, and we'll go get your player data along with it, because we're not going to send all the player data with the player because they could just spoof what they have. We have to check the database for that. And they could check the database directly, but I think there's some security issues that go along with having a direct database connection on your game server. So I think it's better for you to direct that through the backend. So we have a little bit of extra functionality in this backend process that's running on your server to be able to handle all of this, this routing of data and getting the player into the server. It's not as simple as open, IP address, port, and you're done. There's some extra stuff that goes into play. We're done, right? I mean, what we did is we had a backend. It was just a process, simple script, probably could write something in maybe a week or two. And we added authentication and a database integration, and we have servers that are running. Maybe we kicked off a bunch of launch server, or, / your project name server.sh. That's how, when you build a Linux server, that's what you run it, how you run it. And we're done, right? I mean, I wish it was that simple, but unfortunately, if you would like to scale globally and talk about security, latency, or your scaling abilities, then we're just not quite there. That one single backend process, running that script isn't going to scale in production. You might need more than them. And so what I did with Redwood is I put a backend in the backend, so you can backend while you backend. And this, if you remember from our chart, becomes a lot more complicated. It becomes this. And before you get overwhelmed, we'll break this up into a couple of pieces. So the first part is, look, we separated our backend into a backend and front end. And the reason why we did this is, as players connect to the backend to authenticate, when I say the backend, when they connect to Redwood to authenticate, they will create a network connection. And you can only have so many network connections open before you have to scale the server to have several instances of that microservice. And that's going to scale differently than the needs to run the servers, do the orchestration, make sure all those token passing happens, and all those extra backend features. So we separate these so that you can scale your front end part of the backend. Yes, it's confusing. I'm sorry. To the backend. And so you're actually going to see the front end is going to scale a lot faster than the backend, because the backend, Redwood's backend, will scale a lot less than Redwood's front end. I wish I had better words for it. If you got something in chat for me, I would love to hear your suggestions.
I'm following along, though. I think I'm getting it.
Great. So we did something else. because all of this, remember, was this before, and all bundled up into these two components. Those were two, that was a process and a database. Now we have 6 processes and 3 databases. But what we did is we separated this idea of a director that's going to handle authentication. It's going to handle getting, managing which realms exist. And then we have what's called a realm. And this is just like a abstract representation of the game features that the Redwood backend supports, and kind of instanced out. You might have something that's in the US or Europe, and that's really just for latency purposes. I mean, there's scaling abilities there, but the whole point of this is so that your database is close to the players. And so all of your player character data, your world data, all that's going to be stored in the realm database and separate from the director database. And so this makes it actually very flexible for various different reasons, not just to have region support. It's to have other things, like maybe you have different game modes, like you have a PvP and a PvE game mode, and player progression doesn't actually scale well between the two. And you don't want a player's character in PvP, for example, that may progress faster than PvE, and be able to hop that character into PvE, and now they're OP. They're just not something you want. So those would be 2 separate realms. They would have a character in one and a character in the other. Maybe you have a seasonal kind of game and you're trying to play test your new season. Well, maybe you could duplicate a realm. All that data is over there. Some of the players are going to participate in this play test for this new season, and that will have some extra logic and stuff, and they'll work on this database that you could just throw away when you finish the play test and everyone hops back into the other stuff. So having that flexibility to have this other realm without modifying the live service, for example. And then you also get this really interesting thing where you can have both studio hosted and player hosted realms. So if you want to have like a Minecraft Valheim kind of situation where players can have their own worlds, but you also have your own official, worlds running, but you don't want your entire player base to have different authentications, like, oh, wait, we got to authenticate to this one over here. No, so Redwood makes it super simple for you so you can authenticate with one, figure out which realms are available, including player-hosted ones, and to log into there. Tina, any questions up to this point?
Not directly off of what you said so far. So
great.
We're gonna keep going.
All right. So now that we have all of this processes that are running, we have 6 processes and those scale. And this is just only some of them. I've made this a little bit more simpler. There's extra services that you have to run so that you can make sure you're scalable. But running all of this now gets operationally difficult. You have to run a bunch of different stuff, and it gets a little overwhelming. So you need to make sure it's reproducible, not just for production. You want to make sure that every time you upgrade your services, you have a new game version, maybe you have some new backend features. You want to make sure that you don't have to worry about the backend coming up and operating functionally. So you need to make sure it's reproducible. If like a backend service fails, you need to make sure that it's recoverable. And what I mean by recoverable, the service will automatically restart itself because it got into some bad state, and you're up on the you're running in the races again, and you don't have to do anything. And then scalability. This is all about scaling. Because you're an indie game, you're going to build something that don't need a whole lot running because you're just in development or small play tests. And even AA, AAA studios do small play tests. And then later we need to make sure, okay, let's turn it up to 11 and get all the scalability. So the first way to do this, traditionally speaking, is you need to containerize each of those processes. That director front end, the director back end, realms, those all get into a container. Use Docker for that. There's other options, but Redwood uses Docker. And that makes it so that you could just say, I would like to run this container, and here are some parameters. That is in a fixed configuration. You don't have to worry about it. It will come up just like that. And but now we have to somehow run all these containers. We need a way to orchestrate them. So we need a way to do orchestration, and the de facto gold standard is using Kubernetes for that. That is what Redwood uses to manage which containers get booted up. It also says, hey, I would like to scale these when I get 700 players connected to the director front end. I would like to have an extra instance of the director front end so that we can then direct them to that. We also have to have a load balancer. So when that traffic comes in, we know, okay, well, this instance of the director front end is at capacity, but this one is light. We need to direct the traffic to go to this one. So you have to have all the load balancing in play as well. And so Redwood helps by providing you a totally ready to go, ready to launch configuration to Docker containerize all of your microservices that come with Redwood, as well as the Kubernetes configuration to make sure that they will get deployed and then scaled when it's necessary to scale them. But now that's great, but we still have to deploy this stuff. We haven't gotten around, like, we just added wrappers around the script. We had a script. Okay, now we have a container. We got to run the container. Now we have an orchestrator. We got to run the orchestrator. So now you need what's called infrastructure as code. And this is going to help you not only deploy Kubernetes and all of the resources that come with Kubernetes, it's also going to help you with deploying to your cloud of choice. You need to say, hey, AWS, DigitalOcean, Google Cloud, whatever it is, I would like to deploy, and I would like to create a Kubernetes cluster, and I have all these dependencies and all these other things that we have to install, and then we have all these containers and all the scalability stuff. I want to make this so that I run one script and everything comes up. A popular option is Terraform, and a new one that's kind of like a infrastructure as code, but as code. Terraform's kind of a declarative language scripting kind of thing. Redwood uses Pulumi so that you can not have to learn yet another scripting language. And all that does is you say yarn deploy and your configuration environment name, and Redwood will handle all of this for you, both in development, like on your local machine, as well as in production. So you can test what's going to happen in production on your local machine using the exact same single script. Okay, Mike, we get it. This stuff's hard. But you told me we can't, like, using a service maybe is not the best option if I have specific needs. And building myself is not a thing. So what's this Redwood thing that you keep talking about? Well, Redwood is a self-hosted, which means you will pick your cloud of choice and deploy to that cloud. And it's highly flexible. So I made Redwood so that I would not have vendor lock-in. I wanted to make sure that if down the road, Microsoft taps on my shoulder and says, hey, like, we want you to switch all your stuff from AWS over to, Azure. Here's $300,000 of credits. And I want to be able to do that like overnight. I don't want to spend months to do that migration. So Redwood makes that super highly flexible. And as I mentioned, we provide all of the deployment tools so that you don't have to manage, you don't have to worry about the basics, reinventing the wheel to get those services onto the cloud. And first and foremost, I'm an indie developer. I was building my own spell-slinging MMORPG, and I built Redwood to support my use cases as an indie. But the whole point of this talk and what Redwood is all about is that I have ambitions that will scale, and it needs to be scalable. So it would be silly for me to give you a backend that would have a cap that wouldn't be supporting of a bigger studio, because now you have to throw it all away and go find another tool. And that's just not an option. So it's scalable for those larger studios. and it works with most genres. So I was solving the RPG perspective, which is kind of like a niche, but it's part of the bigger problem, which is online service multiplayer games. Basically, everything that you need to support the match-based stuff, the RPG is part of that. So if you have battle royales, racing, shooters, those kinds of things, you need a match-based game. Redwood supports that, as well as the more persistent stuff that needs to run 24/7. Tina, how are we doing? Any questions so far?
We're doing good. There are questions, but none of them are like directly related to what you're saying. That's why I'm letting it go.
Great.
We'll still
I
answer them later. Do you want to make
just
sure
want to make sure
say
that I give you the space to interrupt me.
Oh, I will.
Okay, great. Okay, so Redwood has all this cool stuff. What we're going to cover is just the foundational features of Redwood, what comes out of the box that you kind of get with in less of a day of integrating. First and foremost is, let's talk about the architecture and this flexibility part. Redwood makes it super simple for you to use any of the providers that we provide integration already hooked in. So for example, for matchmaking, we already provide 3 different providers for the matchmaking interface. We provide OpenMatch, which is an industry standard, production grade, highly scalable solution built by Google that you could use in production. But that doesn't work in a Windows environment. So we built like I'm calling Simple Match. It's just like a stub that just gets players into servers in development. It makes it super simple for you while you're developing, and then but the interface doesn't change. So in your game logic, you still make the same API call to Redwood, and Redwood will figure out which of these to do. We have an item is a matchmaking as a service. There are other services that you can add integrations for yourself, and it's as simple as changing a string in the configuration file. You just change this matchmaking provider from Simple Match to OpenMatch, and you're done. So you could have a configuration for development that's using Simple Match, and then for your production configuration, you just change it to being OpenMatch, and that's it. You can have different config environments for your various operating environments. Almost everything is like that in Redwood, giving you the ultimate flexibility because everyone hates vendor lock-in, and Redwood's not about that. Redwood's about giving you the flexibility. So now that we've covered what the architecture kind of looks like, let's talk about data persistence. This is like a really important thing that most people are trying to figure out, because they're working with save games traditionally, and how does that work when we start thinking about servers, scaling, and we talked about multiple regions, and things are coming up and down. How do we do upgrades? Let's talk a little bit about that. So your first option is using what's called a blob or document store. Most of these service-based options provide this. It's really just a place for you to store a file of bytes, anything you want. You give it a key, like the player's ID or the character's ID, and then you give it this file, and you're good to go. It's this most simple option to get integrated with because you're already using save games probably during your prototyping state, something you're familiar with, and it's just the easiest option. But you don't have any querying capabilities. So if later down the road you wanted to create an admin dashboard to be able to say, I would like to know all the players that are level 5 that have at least gold, the 5,000 gold in their inventory. Well, you will have to download all of the files, then deserialize them using probably the Unreal archiving system. So you're having a C++ program now, and maybe C#. And then you have to deserialize all of that, load that all into RAM, then you can do your filtering. There's just no querying whatsoever. Now, you can have JSON blobs, which is like you have a database, but you can still store things as one big blob. It's still really easy to work with. There's some integration, and you get some extra querying capabilities. And then lastly, The JSON blobs, this would be like a single field in the database that you don't have to change at all, that just stores whatever JSON. So you can serialize all of your ustruct information, and that Redwood will actually take that ustruct, serialize it for you into JSON, and store it in the database. So you don't have to worry about how to get that data to the to the database. And then lastly, you have a structured database. This is an option if you would like to have ultimate querying capabilities. It's a lot of work. I won't go into the details right now. But if you're interested, I can give you a rant later of about like why this option is probably just too complicated, too much work, and it's probably not worth it. But Redwood supports all of these things. Redwood gives you the blob and document store if you would like to just use save games. We give you a function to say put the save game into the database, and then get it done. Redwood also makes it super streamlined for working with the JSON blobs. I think this is the sweet spot for in between just storing data in one big blob or storing stuff in a structured database. This is kind of like something that it gives you both best of both worlds, and Redwood makes that super simple. And then you have the option to change the database schema if you would like when you use Redwood. I recommend against it, but hey, if you need it for your game, there's the ability to do that. Remember that control aspect. You have complete control. So now we're going to talk about ticketing and how Redwood handles ticketing. Well, we need a matchmaker for those match-based games. We also need a matchmaker for RPGs, which we'll cover a little bit later. So matchmaking is when players want to get into a server. They say, hey, I would like to get in a server. I have this region, but I'm okay with other regions. So here's a list of all of my pings to all the data centers, the regions that you support. And here's my skill level, my preferences. Maybe I want to do this one game mode, and I want to find other players like that and put me into a new server. You could also go into existing servers. That's called backfilling. And these are typically for ephemeral matches, which means it just starts and it has some definitive end at some point. That could be a while from now, or it could be a very short match. Redwood also provides queuing capabilities. So for persistent open world RPGs, the server's on all the time. We don't need to match make. The player already knows they want to go into that server. They've picked a realm because that's where their friends are playing, or that's what's closest to them. But we only have so much capacity for these like massively one place fits everybody. So we need to be able to handle a queuing situation when on launch day you have way too much interest and your servers are just not keeping up with it. Redwood tries to make it so that you don't have to wait for a server, but in that event, we still need to have a queue. And this also works for like match-based lobbies. So think like Battlefield or Counter-Strike, where you have some server that's just looping through several matches and players just kind of go from match to match to match. You would want to be able to queue into those kinds of things where you have a list of options for you to pick from, and queuing would help with that. But queuing isn't just, a line, a simple array. It has extra things. We have to say, okay, well, we want to go into this RPG. Well, which zone and which server in that zone do we need to put them in that will fit the capacity? So there's some extra things that go into that, which we're going to cover very shortly. But Redwood handles these for you. All you really have to do is there's a function that says join matchmaking and join queuing. And we'll show those when we hop into the engine a little bit soon. Lastly, you have to get the servers to run. Remember we had all this set up for getting the backend to deploy, but we didn't talk yet about game servers. Those are slightly separated, but the backend is responsible for orchestrating that, even if you're using another orchestrator. So yes, we got to put an orchestrator in our orchestrator. Everything's redundant here. So Redwood provides two big options. You can use self-hosted. So that would just mean your game servers are running in the same Kubernetes cluster that the backend is running. And we use Agones, which is another Google open source popular tool for making it super simple for you to deploy your games in a Kubernetes cluster. And you get a little bit more control. It's a little bit more work, but you do need to have a cluster in each region that you want to support. And that could be costly for in development, small scale games, especially match based. But it's great for persistent games because your servers are going to be on 24/7. And the other option can be expensive in those cases. And that's on demand services. Like that is stuff where you just say, I want a server of this type. And it's like, I got you. You don't have to worry about anything else. I'll figure out, well, you'd probably say which region, and I'll figure it out how to do that. It's super simple to get set up. You get access to basically the whole world without doing too much more. You get like on demand service pricing, so you don't have to pay for warm servers, which you would usually do in an Agoni situation. Servers have to be idle and ready for players to hop in, for players to hop into them. So you have some extra idling resources. But the on demand stuff doesn't require that until you start wanting to scale higher up. And so it's cost effective for lower scale match based games. Redwood gives you the option to do either of these. And down the road, I want to make it so that you can do both. So, like in an RPG, you might have your persistent ones in an Ogones, but then your instance dungeons and raids would do an on demand service. So you can boot those up somewhere else, but near the data center that you're running the overworld. So, when you get all of this, the cool things that you get to do is you can start scaling your game servers in unique ways. And so Redwood supports sharding, and that's sharding with a D. And sharding is the ability to scale individual zones. You can break up a map into multiple zones, which are abstract representations of some area on the map. And then you can scale all of those. It's called horizontally. I'm doing a vertical horizontally so that players can get put into different shards. You might be familiar with some other MMOs that would do something like this, and Redwood does support that. A shard is just an Unreal instance. It's the server, and all of Redwood's matchmaking, RPGs, whatever it is, everything is going to have a zone, at least one, and at least one shard in that zone. Unless in some particular cases, maybe you don't want to have an Unreal instance running for every zone until a player gets to that zone, Redwood will support that as well. So the best way to explain what sharding is, I think, is through visualizing it. So I created a little simulation, a visualization of how Redwood does the sharding for you automatically. And I sure hope there's some great clips at the end of the day with me saying sharding so many times. So what we have here is the RPG template project that comes with Redwood, already integrated with Redwood and ready to go. What we are seeing here is the map. We have a village, which is kind of where the players will spawn in. This would be like high density things usually, and some outskirts around this village, and where you could like find some rocks, chop down some trees, be close to the village to do some more things. Then we have this mountain pass, which is kind of a cool little passage. That is another zone. So the village is one zone, the outskirts is another zone. This mountain pass is a third zone, and then finally we have the forest as your last zone here. And what we're going to see here is normally in this case you would have a shard running in all of your zones so that when players get to that zone, you don't have to wait for the shard or the Unreal instance to get into it. So, but for visualization purposes, I'm only showing them when they get into it. So we can see here that we have a shard for the village zone, and players have started spawning. These little dots are simulated players here. And they're going to start traveling to around the entire area over here. And at some point, they're going to get outside of the village. And you can see that they've started going into this other zone. This red zone is the outskirts. You can also notice that we hit our player maximum for that first shard in the zone, for the village zone. So we added another shard on top of that, and Unreal figured that out. Or, sorry, Redwood figured that out for you. It said, oh, you told me when we hit 25% capacity to start up a new server so that we can have one ready to go when players need to get into it. So Redwood said, we got to that capacity. Let's start up a new Unreal server for you. And when players queue in, they just say, I want to go into the village zone. And Redwood will handle to figure out, okay, that server's ready. We're going to start putting you over to the new shard, and it'll route that for you. And when players come over to the outskirts zone, Redwood's going to handle all that transferring, traveling for you. It's going to say player wants to travel over here because they reach some point, server authoritative, and the server's like, we want to travel the player. Okay, well, what we're going to do in the back end is we're going to say, yes, we can transfer them. Here's the shard that they need to go into. Also, here is a new token, because remember, we got to make tokens so that they can go and get authenticated, so that when they go into the server, all that data can get synced back up of where their current location was and put them in the right place. A lot has to happen under the scenes, and Redwood handles that for you. Oops, I started over. And so we're going to start speeding up here, and we're going to start seeing some zones, shards come up here for the outskirts zone. They started traveling down this mountain pass, and what you're going to start seeing is when the shards become empty, we don't need them anymore, and Redwood will bring those down so you just don't have idling resources anymore. And this is zoning and sharding in that's really all it is, but a lot has to happen for this to happen automatically underneath the hood, and you don't really have to worry about it. It's super easy to configure what each of your zones are, what the sharding requirements are for those things, and Redwood will just manage this for you. Okay, so Redwood is a backend that's going to be able to quickly get started with a project that has zones. If it's matchmaking, we will only have one zone and one shard for that zone for that Unreal server. But for RPGs, we might have various different scalability. Redwood's also going to scale horizontally all the microservices in the backend so that when you have players starting to scale to connect, we want to make sure that the network card or the process isn't going to fail because we have too many connections. And then we deploy all of this with a single script that just runs, and then everything gets deployed, including your game server configuration, to make sure all of this happens easily. So what we're going to do now is we're going to hop into the RPG template that comes with Redwood. That is a so the whole thing that we just saw in that visualization, that's a project that you can download with Redwood and the backend and get started real quick. So let's hop over there, and I'm going to show you some of these features in Unreal. Okay, so what I have running here is I have the backend running for you, Redwood, which is as simple as running yarn dev, and then you provide the configuration environment. So template RPG, that is what I have run in the backend. Sorry, before the stream. Can't keep using the word backend. We already have too many backends. Okay, and we're not going to go into the details here, but what has happened is we booted up a alternative for the database so you can run it in your Windows environment without having to use Linux, because Postgres is going to run in Linux. There is a Windows option, but this is easier for development. And we started the director, we started the realm, we started our ticketing services so that we can do queuing and matchmaking, and everything has come up for us. So what we're going to do now is create a character, show the data persistence, and get into the world. So I have a little titles menu screen here. I'm We're going to go ahead and create a user by registering this. This project, remember, is everything you get. So everything you see from this point forward is something that you get to download and play with yourself. So we're going to register, and we'll register, automatically log in, and let's go ahead and create a character for this realm that we have also gone into. So we got a couple of different customization things, this fun little character like this one. And then now we're going to press join, which is what is going to happen is we're going to run that join queue function from the client. And Redwood is going to say, okay, I know the zone that you want to go, the village zone, and I'm going to figure out which shard to put you in. There's only one right now with no capacity, so that's the one we're going to go into. All right, so we can see that we're here running around in the village zone. We can gather some coins, which you can see in the bottom right here. And that's saving stuff to the inventory. I think it's every quarter at 4 hertz, I think is configurable, but I think the default is 4 hertz. Redwood is going to say, hey, your inventory changed. Let's persist that to the database in case the player crashes, the server crashes. We want to make sure that that data gets persisted to the database so that when we load everything back up, or if they switch between zones or shards, that we can retrieve that data. We have an example of like using a merchant. So you can buy a gem using these 3 golds. And you can also have like a little bank here. Just some examples of how to use things that you would normally find in like an RPG, for example. So we can store our 1 coin left over into the bank. And what we're going to do here is just kind of do a quick re-login, show that everything got persisted. Underneath the hood, all we've done is just said our inventory changed, and Redwood would monitor that at 4 hertz, which you can configure, and said, okay, it has changed. Let's go persist this to the database by taking this struct, serializing it to JSON, throwing it over to the database. It gets persisted, and then when we log back in, everything is going to be there. So we're just going to log in real quick. We could see our player is still there, though kind of already saw that. We can check our bank, for example, here. You still see our 1 gold is left in the bank. That's all great. And 1 gem is in our merchant store here. So we have just showed kind of like what persistence looks like. What I'm going to kind of show is what persistence, like the setup is for using this system. Let's go ahead and just stop the editor for now, just so I can show things around. So all we have done is we've set up a couple of variables, and we've added these Redwood character component that comes with the Redwood plugin when you download everything. And you don't have to do much with this. You can keep the defaults to say, hey, these are our variable names, and we want to use them. And then you just add those variables in here. You could use any struct type. So all you have to do is set up your structs. So we have one for the character creator data. So this is what happens on the title screen, and we pick all of our stuff when we create the character. And Redwood will automatically, when the player logs in, checks that token with the backend, and that would be the Realm backend, for example. And then the Realm backend says, here's the data in JSON form. Redwood's plugin will take that JSON, deserialize that into an Unreal struct of your choice. You don't have to do any configuration. You just had to check, I want this Unreal type, and the data will be there when the player has finished its full startup sequence, and the Redwood system gives you a notification when that's all finished. And then when you're ready to change that, all you have to do is, so we have this interactable class, which is inheriting, this is part of the project. but it's inheriting from the Redwood plugin. There is a interactable class that handles kind of a bunch of stuff underneath the hood. That's when you gone into like the coin, for example, and saw the press F to interact. Well, then this event gets fired, which you can override in your class on interact. This happens on the server, so you can already know that this is authenticated and in the authoritative environment. And we do a couple of quick checks. We get the equipped inventory. This is just a little blueprint function that all this does is it changes this equipped inventory and adds this quantity for this ID. And we can show you what the equipped inventory looks like in this inventory struct. All this is a map. The map doesn't get, they both get serialized, but the map can't get replicated because maps don't get replicated, but the arrays do. And so Redwood will kind of make sure that all that kind of deserializes a little bit for you. And so all this function is modifying this to add that quantity. And then we get that character component that we saw attached to the character. And we call this function to say our inventory is dirty. The next time you're going to do all of the persistence, make sure you gather this. And then Redwood will automatically figure that out and send that over. Okay. Tina, how are we doing on time?
Oh, we're doing great. You've got plenty.
Great.
We're at it is 53, so not even an hour
Oh,
yet.
I can look at my clock too, I guess. Okay. Cool. So that's data persistence in a nutshell. Oh, before we do that though, let's talk about that blob and save game storage. So Redwood also makes it easy if you choose not to use this system, which I highly recommend. I think it's really flexible. Redwood does some extra things by giving you a system of using migration functions. So as your structures change, which they will, you'll add variables to them. You're going to have to migrate your data because players might not log in for several months and have the old data stored. So we have some extra stuff to help you with the data migration. But if you want to kind of do everything yourself using your own save game or some other binary situation, we have a couple of functions. So we have a put blob and also a get blob, as well as the put save game, as well as a get save game. And so with the blob, you just give it an array of bytes. You can figure out how you format everything. This could be just a string that you serialize into an array of bytes, or you can use any save game object, and Redwood will use a system that you can configure where that gets stored. That just uses like an S3 bucket. If you're familiar with AWS S3, it's any S3 compatible API. Redwood gives you an option if you want to self-host that, or if you would like to use a third-party option. There are plenty out there that will just store that. So you kind of get that similar blob document store as well instead of using the JSON kind of magic that Redwood does for you. Okay, so we're going to reset this so that Unreal doesn't complain again. And watch is going to complain again. It did. Okay, so we're going to restart Unreal. I thought this was going to happen.
It happens.
All right,
Happens to the
not going to
best
take
of
that
us.
long. But while we wait for Unreal, we'll talk a little bit about configuring things. All right, why you kill you? Okay, so when you want to configure your different zones and shards, we have this idea of game profiles. We have one for the overworld, which you can see we have these 5 different zones, and they each use the overworld map. As you know, that we're just working on the same map. They're all going to get loaded with these maps. There's a data asset on the Unreal side that takes this ID and figures out which actual level instance you want to load. Redwood automatically figures out and does all of the booting up aspect of things. So you just have to configure it over here, as well as setting up that data asset in the asset registry. We also didn't talk about the mine, which we're going to show you in a second. The mine is loading a different map. So zones can be anything. They don't have to be all in the same map. They can be different maps, and they can also shard as much as they want going through that. We haven't gone into instance dungeons yet, but we're going to cover that very soon. Okay, we are back up. We're going to go to our maps, switch over to the title screen. We're going to open all these things that we had open. We're going to log in again. Okay, so now I'd like to show how the zone transferring works. And if you remember, we're in the village, and if we go walk towards the outskirts, what we're going to see is we're going to have like a little bit of a hitch of us going between the village zone and the outskirts zone. You would normally show a loading screen during this. Perhaps you might have to wait because your servers are at capacity and we're waiting for a new zone to get started, or a new shard to get started up. But what happened is we went through a barrier, and that when we did that, the server says, hey, we would like to transfer, and we did that whole handshake process that we've talked about getting a player into this new zone. It figured out which shard. There's only one still, so we did that. The same function, it allows us to do fast traveling. So all that same technology has given us this extra feature to be able to fast travel. So we're going to go and fast travel to this mine that's in the middle of the mountain pass. And so this is a whole other map. If I show you real quick, this would, we had the overworld, and then we have this mine map, and this is running in a server that couldn't shard as well. And what we're going to show you here is matchmaking inside of the system. So Redwood makes it so that you can do both at the same time. You can have queuing for your overworld stuff, but if you want to have instance dungeons or raids or things like that, you still want to do matchmaking. You say, I want to be in these certain regions, and I have these skill levels. I want players that are near me. I want my party to come along with me, those kinds of things. And so we have a little bit of a dungeon thing here. When we start, I didn't create a UI for this, so you can just see at the top left where things get printed out, you're going to see the status of us joining matchmaking and having a server allocated for that and whatnot. So we've joined the matchmaking, and what's happening behind the hood is Redwood is waiting for some period of time that you can configure to say, hey, let's just wait a little bit to try to get as full of a match as possible so it's engaging for the players. We waited, that time was 15 seconds. We found a match, a server has been allocated for them, and now we're booting up a server. And we go take a look at the task manager here. We can see that we have all of these Unreal Editor exes running with the dash server command, which acts like a dedicated server. So you don't normally, when you're running dedicated servers, you want to package one, you have to compile Unreal from source. But with Redwood, you can get started with development and do most of your development without doing that quite yet. Eventually you will have to, but you can still play around with everything, because what will Redwood do is run this command for you instead of using like the whole Ogones thing where it's a package server and whatnot. And we had 5 zones plus our matchmaking, so we should see 6 servers, which we do. We see 6 servers running, and so here we're in our dungeon, and just a cute little room here. And what's happening is we have like a little bit of timer that's left to say, hey, the match has ended. We have to figure out how to get the player back to the overworld, which is running in a totally different proxy, and which is just how we do representation for the various different server infrastructure. I could cover more, but I won't go into too many details. But we have a game server proxy with a collection, and in that collection we have a bunch of instance containers which have instances. There's a lot, but what we do to do that is so that when you work with other service providers, when the logs are collected, they're corrected in the right order and in the right place. And if you have uh, your realm, you want to bring it down to upgrade it or something like that, all that data is still persisted in this abstract proxy. And when the servers come back up and loaded, then it goes and grabs all the data from the proxy, and that's that game server collection. But we're back here in the mine, and we can go and travel back to the mountain pass, and that's matchmaking inside of uh, an RPG scenario. I call it instance dungeons, but it works the exact same way you would with normal matchmaking. So if we take a look real quick at let's open up that map. Okay, so we have the mind map here, and this is kind of this tool, this little it's called an interactable, and this is a special type of interactable, which is a proxied interactable. So when you build user interface things like merchants and prox and like something like this, where you would want to have like um, a user interface when you go to this dungeon door that says I would like to do matchmaking and here's my preferences or here's my party or whatever it is, you want to make sure that you can do the replication properly. And if any of you are familiar with doing that replication, for a client to talk to the server, the actor needs to be owned by that player. And so what ends up happening for kind of the newbie approach is you would put everything in the player controller or the character, like the pawn. And that just has a bunch of unrelated logic to say, hey, I would like to join this thing, but that's the thing I own, so I'm going to put the logic over there. What that does is that creates a bunch of hard references to everything else, unless you can make it really cool and easy to use interfaces or something like that, but you don't make the hard references anyways. It becomes a spaghetti mess, and it doesn't scale really well in terms of like operations and development and things like that. So Redwood gives you a easy to use proxied interactable so that it handles when you go up to the door, press to interact, it's going to spawn a proxy actor for you, set the player as the owner, and then now you can put all of that replication logic or the like RPCs inside of that one proxy actor, so that you can have this logic as decoupled as possible, which is great coding practice. So we can have we set our proxy class as this dungeon proxy here, and similar to oh yeah, so this is the interactable. We don't have it on interact because that all handles the base class will handle all the interaction. It will spawn this class for you, set the owner, all this stuff. When this gets created on the client, you can then spawn like or you can make a widget and attach that to the viewport and do all of your RPCs right here in the proxy actor. Uh, what we're doing here is we're just joining matchmaking. We're saying we can join any of the regions. We have no preference there. And this function will go and get the pings for each of those regions and send that over to the backend. And the backend will use the match function to figure out which is the best, which is our only region, which is my local machine. But in production, it will assess all of that for you. And so this was just that's matchmaking. That's how it's handled in the match template, which is the basically just Lyra packaged up and integrated with Redwood. And all this is those status messages, and then we're over. So that's how we do matchmaking, how we get into a match. Once we're in that match, let's go and take a look at that dungeon asset. So open up the dungeon. Don't judge me. I just changed the level blueprint for ease of use, but you would maybe not do this. But so we have the level blueprint here, and when this begins, this is just to manage the state of the dungeon, the match, and to be able to end the match and get players back into the main server. So we check to see if we are the server. We set a timer every 15 seconds, and we decrement some timers. So you can see here we got 60. So this will happen 4 times. After 60 seconds, what will happen is we will continue on, and we'll say the match has ended. This is just a multicast RPC to just print the string so that the client can see it. And very simple, just something to kind of demonstrate how you can use the system. We tell the Redwood system that we're shutting down, and that's just going to set a status in the backend so that if you have like a dashboard or something like that to monitor these things, you can see that the state goes to shutdown. And that just means that we're getting ready to end the game server instance, the shard, for example. We wait a second, we get all the players. Let me toggle these away. And then all we do is we say travel the player to a zone spawn. It's very similar how we go into the mine. This is how we do fast travel. This is also how we do from going from one zone to the other zone. We just call this function to say, there's another function to say instead of going to a zone name, you go to a specific location, like travel player to zone transform. And so we use this when we travel between zones so that the player's off location doesn't change. But otherwise, we can say we want to go to a spawn name, which is like a dedicated, just an actor on the floor, which I can show you after we get out of this level blueprint. And then we specify this parent proxy because we have to somehow, this server is running separate from our overworld that has all of these zones. You can see here that it's a totally different game profile. So we started all these things up, and then when we wanted to run the instance dungeon, we have a different thing. It has just one zone with the one map in it. You can add more maps to, and Redwood will automatically pick a random one for you. And some matchmaking preferences, and we got to figure out a way to get back into that. Well, with this idea of a parent profile ID where it will be able to find the proxy with all the other stuff, all these other zones that are running in there where we came from, and that gets all automatically passed down to the game server for you, and you can access that proxy ID here and push this in so that the player can be traveled to the right place. And that is the dungeon. And then when I was just talking real quick, we're talking about those zone spots. This is just an actor. It's called a Redwood zone spawn, and it just has some strings of like the name of it, and that's how we figure out where to spawn in each of these. So this is like when you go into the mine from out up above, and this is when you come out of the dungeon. So that is matchmaking and dungeons and stuff. Did we not cover something? I
think so.
think that was quite a bit of information. Do we have any questions around kind of this RPG template, the things that we've covered, um, whatnot? We can also go into the Match Lyra template and kind of show that. There's also a live demo. Like I have what you would be able to deploy to the cloud is running. If you go to Redwood, the link is in the description somewhere, but redwoodmultiplayer.com, and there's like a demo gameplay templates and demos link. You can download the client and boot into a server if you wanted to just kind of play around with it, play some friends with Lyra, and you could also download the project as well. So yeah, Tina, I think we're probably ready for some questions.
All
I
right.
can dive into any of these specifics, but I don't want to just dive into something, you know, and rant.
Well, this is the time and place for it. I think that's what we're all here for, so no worries there. But yeah, we can dive into some of the questions here. Um, let's see. I'll just kind of start at the beginning. It might be a tiny bit back and forth between some
Sure.
topics, but that's all right. We can rapid fire, right? We got this.
We got this.
All right. So the first question here is server meshing with seamless travel possible with this?
That's a great question. Seamless travel is something I really want, and it's something I've been actively working towards. It's a non-trivial thing to solve, but I'm actively working to that. And generally speaking, what has to happen is, if you could share my screen real quick.
There we go.
So here is this zone transfer. It's just a blueprint spline utility that comes with Redwood where you can set up each of your different zones easily. You can set up zones however you want. If you want a grid based system, you can implement that as well. So, what has to happen is this would normally be like a wider corridor. And when players would enter one from the side that they're coming from, what would have to happen is we'd have to say, hey, we want to transfer to the other zone. We would figure out the shard that they need to connect to. They would then open up a new connection in Unreal so they maintain connections to both of them. We would sync some state to make sure that the player's, position is synced so that it truly is seamless. And when that finally happens, we would drop the previous server and maintain the other server. And the tricky part is to make sure that I can do this in a way that I don't modify the engine source, because I just want to make it so that you don't have to fork or integrate my stuff. So just making sure that we can do all of that where it's just all provided in a plugin that you can just add. That's kind of trying to figure all that. So it's coming soon. You can follow the roadmap, and we can talk more about that.
Very cool. Next question here was they said, I see mentioned on your website that you support open world and RPG. What about a game that is both open world, RPG, and matchmaking all in one? Would that be something that this could support?
Absolutely. So the we kind of just demonstrated a little bit where we did have the RPG and we did have matchmaking inside of it. You could have more complicated setups where, when instead of transferring between from one zone to the other zone through the queuing system, you could have, when you got past that barrier, you could have done matchmaking instead, and that's going to go and open some sort of ethereal world. So, like maybe you are going through, you kind of have this open world scenario, and you're going to get to this gate, and behind that gate is a whole other world that you want to have in a matchmaking kind of like scenario, including backfilling and all that stuff. You just change the function that you're calling for it.
Very cool. Next question is, would something like this help with the lag that can come from running an anti-cheat on multiplayers as well?
It's a great question. Um, Redwood, primarily, most backends will not necessarily operate with the game itself. Not meddle with replication and things like that. Um, Short answer is not necessarily. You're still going to have to solve those kinds of problems. If there is a use case where I'd like to be able to say, hey, yeah, let's provide some best practices like I've done with the other kinds of things that come with the plugin, I'd love to add that in there. But I'm curious about your specific uses. Hop into the Discord and love to chat more.
Definitely. This next question you may have addressed, but I'm going to ask anyway, just in case
Sure.
anyone popped in a little later, because it's some good info for them to have. What is the maximum amount of scalability that someone could look at utilizing Redwood?
That's a great question. So scalability can come in two flavors. You have the horizontal scalability. So just adding more shards, adding more microservices, and that is generally boundless. We haven't tested specifically what that number is going to be. But generally speaking, the goal is 1 million CCUs or concurrent users across all your different servers. We're in the next month or two, we're going to be able to provide like a whole documentation of doing all that load testing, scalability, and trying to hit that target. Um, their other side of scalability is how many players can get into a single Unreal instance, a single shard. Uh, and that's probably the elephant in the room when we talk about scaling multiplayer games and MMOs and RPGs and things like that. 100 players isn't quite a lot, and you like to have more people. That's also something I'm actively working on in the next few months to be able to provide best practices, whether that's not using the character with the character movement component and moving to something like the Mover plugin or something else, using Iris, a new network plugin, part of Unreal with network prediction and things like that that can help with some of the scalability. Then you can also do some things like changing what collision is being replicated. So maybe instead of a capsule, maybe you have like a simple box. It's a little bit simpler. Don't replicate all of the movement. Treat things as like PvE in a sense where the animations aren't being ran on the server. So then the server doesn't have to calculate everyone's animations. It's just moving a point in space. And then clients can just do that for the players that it sees. Because ultimately, it's about how much the server can handle. And then there's this part about replication and making sure that you um, don't replicate too much so that your network bandwidth doesn't get out of hand because it becomes an exponentially difficult problem. So hopefully in the next few months, I'll be able to help solve kind of like how you do like testing what your load is for a single Unreal server, like what is your capacity, and how to do the profiling for that to figure out what the root causes are for issues, and then being able to like maybe take a couple of best practices and apply those to your game to get you some better optimization.
Awesome. Very cool. Is it possible to use a launcher binary build to build a game utilizing Redwood?
Great question. So yes, so you won't be able to deploy to Kubernetes or to the cloud yet, but um, all you have to do is download the plugin, download the backend, and you can use the, and by launcher, they mean one of these distributed things from Epic. You can use that, and it's just going to work as is, and you can do all of your development in there. Uh, I recommend at some point, not near release, but at some point you start testing how things are going to work in a Kubernetes cluster, and that when you do that, then you're going to have to package a dedicated server. And be able to, and that requires compiling from source. But you don't have to use our fork of the source quite yet, and hopefully that stays true. You just download the source, follow the instructions on Epic's website to do that, and it's fairly easy to do. It just takes some extra time and disk space. But it will be required eventually. You can maybe set up build machines that are separate from your development machines. That's a necessity for you. I did see that, like starting with 5.5, we had some extra, platforms and target platforms that are coming. I think someone was mentioning about how like tvOS was added. One day it would be kind of cool if we could download server, binaries so that they wouldn't have to do that. Hint, hint. Uh,
Taking notes.
But I mean, that would be more work for Epic to do, but you would still just download the extra stuff to be able to make server and client builds. It's a lot of extra space. Each thing has like an extra 15 to 20 gigabytes. So now you have a development build for both of them, and then you have to do that again for both Windows and Linux. So it's 4 extra targets you would need for both the client, server, Windows, and Linux.
Dang. Um, let's see here. Does Redwood support crossplay?
Does Redwood support crossplay? Is that
Yeah.
yeah? Um, so the nice part about Redwood being its own system and you have the ultimate flexibility. At the end of the day, it's just a WebSocket connection, which most platforms support. Uh, and so WebSockets is just something on top of the HTTP protocol. Without boring you too much, it's a pretty standard protocol of sending requests to the backend, and that means that it just supports various different platforms. We're working with trying to make sure that there's tested console support so that you're confident that's going to work on various different consoles. But there's no reason if you release on Steam that it won't work with the players that are going to be on Epic, like through the Epic store. Um, yes, hoping to give you some more documentation about testing that and whatnot. But there's no reason why technically, architecturally, it doesn't support it. And that goes for mobile as well. So yeah.
Very cool. If player count remains fairly low, is peer to peer supported with one of the players being the host, or is Redwood designed to be cloud hosted only?
It's a great question. So Redwood is designed to be dedicated server based, rather than listen server, which is that peer to peer. Primarily, we're thinking you're scaling a lot, being more competitive. Dedicated servers make a whole lot of sense there. It might support listen servers. I haven't tried it in a while, so I'd be interested to see. But one server versus another server doesn't really make a whole big difference. The real big question is making sure that the player-hosted realm is set up and there's extra dependencies to be able to connect with the backend when you host a player-hosted realm, for example. So in addition to running the server, you would have to run extra stuff outside of the server. So ideally, we would package that up as a single executable that included the server itself. And they would either use Steam or a launcher application to be able to say, run my Redwood realm, and that includes the server, includes the dependencies, all those things. So it'd be probably easier to go that route than mixing up, listen server stuff. So ultimately, it would be still player hosted, but dedicated server instead of also running in the same client machine. That would be my recommended path, personally.
Cool. So traveling between shards, is that equivalent to traveling between virtual machines?
Yes. So in Kubernetes, there's this idea of pods, and that pods will fill up in one virtual machine. So they'll like run a bunch of pods, which is just instances of containers. And as you get to some capacity for this one node, this virtual machine, another virtual machine will be created for you, and pods will be added there. So for all intents and purposes, the pod is virtualized and feels like it's its own virtual machine. It's like a virtual machine in a cloud hosted virtual machine. And so when shards are just a pod, a virtual machine inside of a virtual machine, and those are different pods, and you could hop between different pods in this, or yeah, different pods in the same virtual machine, cloud hosted virtual machine. If it has RAM and CPU cores and it's rented, and you're paying for that unit of resource, or you could be hopping to different ones. Redwood will try to just start scheduling them, and those will get booted up as needed.
Very interesting. Does Redwood also work with VR? They're asking because of the performance and amount of data that's different for something like a headset versus a flat screen.
I don't see any reason why it doesn't support VR. I haven't seen anyone try to do it, But as long as you optimize uh, how much data is going out by just limiting how much data there is to go out, and then you configure down the persistence, um, believe in the how often things get persisted to the server, or to the database. That happens on the server side and not on the client, so that doesn't impact VR at all. Generally speaking, if you're doing if you're performing fine with your VR game, doing multiplayer replication in Unreal, etc., if that all is fine, then Redwood's going to support you in the backend, and then all of that extra stuff is just going to happen on the server side, which wouldn't be running on like a headset, for example. That's going to either be running on their computer if they're doing a player hosted realm, or it'd be running on some server in the cloud. um, yeah.
Awesome. How is logging solved, i.e., events or errors and stuff like that?
So logging, we have an initial implementation, but I'm trying to give you something a little bit better than that. And so we want to use Grafana has a whole suite. One of the options of Grafana's tool set is like a just a free solution that you can use self-hosted, or you could use like a managed solution, is Loki, and that's like a logging system. And I want to be able to, so it's just totally automated. You don't change anything. You just enable, or you'd probably be opt out rather than opt in. And you could just say, I don't want to do this. And that will log that all to the Loki instance. And then you could use Loki to filter out different logs and events, and have a better event tracking there. Crashes and errors. I want to add an integration for Sentry. And again, abstracting that, so if you don't want to use Sentry for managing your crashes and things, you could, but that will be also added very soon.
Awesome. All right. Last question I'm pulling from chat here is if you can answer this one too.
Sure.
What syntax is the Redwood Unreal Server correlation written?
Great
And what
question.
language?
So yeah, the Redwood backend is written in TypeScript, running on Node.js. So let me just pull up a sample service here. So you can see we have various different packages here, and we have the director of backend and front end, the realm. We have a sidecar, which we didn't talk about, which runs alongside the game server, and it just kind of makes it so it's easier for the game server to communicate with Redwood. And all this is going to be follow a very similar aspect, where you have kind of an entry point, and so this is like the backend, and then there's a whole manager which like initiates all the different routing and things like that. And you can see there's all these different routes for all the API endpoints. So all of the Redwood backend is in this Node.js TypeScript. If you're not familiar with Node.js or TypeScript, it's just a super easy, SaaS-friendly kind of environment to be able to scale really easily and use third-party systems. And then I was talking about how we use Pulumi for our infrastructure as code. That is like not the backend, but it's a tool to help deploy the backend. That's also written in TypeScript for Node.js. So you don't have to learn a whole other language if you wanted to modify how things are getting deployed. Um, like here we have a DigitalOcean integration, and that's all going to still be TypeScript. So uh, at some point, we're going to also add a game launcher application. So you get to start with like a template game launcher, and that will also be kind of a Node.js TypeScript. So I want to just create one environment that works for everything. The reason why we chose to go through Node.js TypeScript is primarily one, it was what I knew best. It was easy for me to implement something. But two, it performs well enough that you can scale horizontally, and Redwood will handle the horizontal scalability for you. But it's also easier to hire for than writing something in C++ or Rust or Go. Um, and I don't think it needs that extra performance boost, and leverage just the tooling to make sure it's scalable. And then you have this huge ecosystem of tools that you can use, that's all friendly for SaaS, which is kind of what you're doing. Your game as a service. That's what a live service is.
Awesome. All right. Well, thank you so much for walking through all of this with us today. Really appreciate you taking the time to be here and to tell us more about Redwood. Walk through the whole process from beginning to end and explaining it in a way that makes sense, because I do feel like this is definitely a topic that can get uh difficult to follow along sometimes. It feels a lot larger than maybe it even necessarily is. Although it is large. Like I don't want to downplay it either because it's a huge process in and of itself. So thank you for taking the time to break it down in a way that is easily digestible, easy to follow. I understood everything you were saying, which is
Hey, we did it.
we did it. Which is not to say, that I wasn't expecting to. It's just this is a topic that I
Yeah.
myself am unfamiliar with. So being able to really follow each step is was huge. Thank you for doing that.
Yeah, for sure. And this is just the tip of the iceberg, the entrance to the rabbit hole. It goes a lot deeper, and really what Redwood's trying to help you do is start off with just the start, and then start learning components as you need by providing something that's just going to work for you in a default environment. And then as your needs grow, then you can start learning each of the individual components and customizing them as you need. um, Ultimately, got any questions, there's a Discord link somewhere, at least in the YouTube video, and that is just a place for you to come and chat, talk about your requirements, see what we can work with. If there's something that's missing and it needs to get prioritized, work with you and see how you can get started. Otherwise, you can go to redwoodmultiplayer.com and you could just sign up, download the stuff. It's all self-service, so you can get started with the launcher app, Epic Games launcher Unreal version. It sounds like it will work in 5.5 plus some modifications, but I'll be making a release soon to make sure they don't have to make the modifications, but not complicated. And you download the two template projects, either the match template, which is basically Lyra, super recommended if you're doing like a match based game, just because Epic provided so much great stuff for giving you a ready to go, production ready match based game. And then you just cut it up how you see fit. So that has an integration. It's just a project you download. It's just Lyra, but integrated with Redwood. We separated the Redwood integration so you can kind of still see what was originally Lyra, and then what the modifications are for Redwood. And then as well as what we just covered today, which was that RPG template, and everything that you saw today, you can get started and boot that up on your machine. You can follow the directions to go onto Kubernetes locally, and then even deploying that to the cloud.
All right, we'll drop the links in chat here that you were just mentioning. I think they're up there. Yep, they are. So yeah, if you're interested in checking out the website or joining the Discord channel, we've got the links there in chat for y'all, as well as in the description of the video. But before we wrap up, I want to make sure any last final things you want to make sure you say before we end for today.
I think ultimately small studios can do a lot more than you think you can. And having the right tools helps with that. But at the end of the day, you have a great vision, and I think you should follow that passion. You're going to see some naysayers along the way. And if you want to do something really big and really cool, I'm right there with you, and I want to help you do that. So if you got really cool, ambitious project, I say give it a shot. Obviously don't spend your life savings unless you really believe in it. But I think that you're better than you think you are, and hopefully Redwood will help you get to where you need to be.
Love that. Love that. Gotta get our indies together, gotta get these smaller projects and everything together so we can bring them to the maximum potential that they got, right?
For sure.
Yes. Thank you again so much for taking the time to be here today and talking about all of this. And thank you so much, everyone who came to watch the show as well and to ask questions and participate. Wouldn't be what it is without you being here to consume the content that we bring to you, right? So appreciate you taking the times out of your day to be here. If any of you joined the stream at any point after we started and missed some parts, that's okay because we post all of our streams in video format that can be viewed on demand on both our Twitch and YouTube channels at Unreal Engine. You can also follow us at Unreal Engine on all of our socials to keep up with the latest news, know what's going on, all the updates as soon as it happens, all that good stuff there. And then last but certainly not least, if you're not already, please come join us on the Epic Developer community. We host things like our documentation, tutorials from both Epic staff and the community. Our forums are there to answer questions that you may have, as well as give you the opportunity to meet like-minded devs and all that kind of good stuff as well. Lots to do there. So much. I cannot emphasize enough how much is there, the developer community. So check that out if you haven't already. And yeah, last thing is tomorrow, slightly different time than usual. We are having another stream at 10 a.m. that is all about Fab. We're going to be walking through a demo of Fab, tackling some FAQ, as well as publicly revealing our roadmap plan for Fab as well. So, and answering questions also from you, not just FAQ. We're also taking in questions live from you as well. So if you are interested in that, make sure you come around for that. I think that's everything. That's everything for now. So thanks so
Thanks a
much,
lot,
everybody.
Tina.
Yes, thank you, Mike. This was wonderful. And we'll see all the rest of y'all later. Bye, everybody.
Bye.